Making solar power cost less is vital if it is ever going to displace electricity generated from fossil fuels. Thin film solar cells are cheaper to make than traditional solar cells, but have suffered from lower efficiencies, meaning less power can be generated from a solar panel of a given size. Kylie Catchpole, one of this year's TR10 innovators, is exploiting the unusual optical properties of silver nanoparticles to boost the efficiency of thin film cells. We asked her how the technology worked and its potential impact on the solar power industry.
Solar energy is a huge resource. If you put solar cells on about 1% of the world's land area, you could provide all of the world's energy needs. So there's no other energy source that comes anywhere near that size. But at the moment, solar electricity is still more expensive than conventional energy. So what we need to do is decrease the cost of solar electricity. And we can do that by lowering the manufacturing costs, but also by increasing the efficiency, so we get more power out for each solar module. Standard solar cells have a texture on the surface, and that's several microns in size, and that's quite a cheap, efficient process for standard solar cells. But for thin cells, which is the way solar cells are going, you really need to have a different sort of surface texture. You can't use the standard pyramids on those sorts of cells, so you need to do something different. So what we're using is these metal nanoparticles to provide that scattering of the light instead. What we're doing is we're putting silver nanoparticles on the top of solar cells. So we have a solar cell, we put silver nanoparticles on the top of the cell. The light comes in and it makes the electrons wobble back and forth on the silver nanoparticle. And then those electrons re-radiate the light, and they re-radiate the light into the solar cell. So that light goes into the solar cell and then bounces back and forth inside the solar cell. So the light is trapped inside the solar cell, and it gives more chance for the light to be absorbed, so you can increase the efficiency of the solar cell. It's a very cheap process. So what we do is we evaporate a very thin layer of silver. The amount of silver that you need is so low that the cost of the silver is a small fraction of the cost of the glass that you use for a module at any rate. Once we've evaporated that silver, we put the solar cell in an oven, just a normal kind of oven, 200 degrees Celsius, and that makes the silver form into little tiny particles on the surface. So it's a really automatic self-assembly process. It's very simple. So this happens when the whole solar cell is nearly finished. So it means that there are no compatibility issues with the rest of the solar cell processing. So we've made solar cells, silicon solar cells with metal nanoparticles on the surface, and compared to a flat silicon solar cell, we get 30% better performance from these cells. People are investigating a range of semiconductors for the solar cells. They're putting metal nanoparticles on different types of solar cells, on organic solar cells or gallium arsenide solar cells. And that's one of the great things about the technique, is that it's applicable to any type of semiconductor. So it doesn't rely on any particular properties of the semiconductor. And they're also using different ways of making the metal nanoparticles. At the moment, we like the way that we're making it because we get a really high density of particles, but we're also looking at other techniques where you can get more control over the size and shapes of the particles. At the moment, we're doing it in the lab, but we're working as part of a large project also with some companies involved to see if we can work out what it takes to commercialise the technology.